the first joint, we got like Sean Murphy.
Okay. Okay. All right. Hey, let's go through a couple notes here. Big thing here today. Hey, we're doing trig functions today. You'll need a calculator. My goal is to go through 2 examples, a normal problem, and then one of the new ones today that we haven't discussed yet, where it's comparing 2 different triangles to find a certain measurement. And I want to talk about that today. So we'll kind of we'll get a glimpse on how that works here in a second. All right. So first of all, here's what I want to do. Let's do a quick problem where we do like a normal SOHCAHTOA problem. Now remember, on Friday we introduced the reciprocal functions. Your calculator does not have these, so I'm not going to focus on these today. This will be something we're going to look at possibly tomorrow, where we'll look at cosecant, secant, and cotangent. It's not going to be a part of the homework today, so I'm just going to glaze over it, and we're going to look at it tomorrow. Okay? We do have homework today. I kind of warned you that last Friday. We had Google questions of the day last week. If you didn't answer any, make sure you go back and do that. But we have an actual worksheet today. It'll be due on Wednesday this week. It's 6 problems. So pretty straightforward. But let's jump right in. I got 2 examples I'd like to cover today. So let's do our first one here. So the first example is, we'll keep it pretty straightforward, pretty simple. I don't want to create anything too complex. I think you have a couple problems that are just short and simple to the point, where you have to find a certain number. Let's say, for instance, I want to find this angle right here. Let's say that this is 30 feet, and this is 16 feet. And I want to know the angle. That could be just a normal problem. That's what I consider. It's got one variable. It's not overly complicated on the picture. Every problem will have some type of story problem that goes with it. As you see it, they'll have the picture, so you can just go off the picture. You don't actually need to use the story problem. I just like to have it in there so you can understand why we do this stuff. Okay, so to solve this one, I still label it, and then we're going to do some of the math here. Let's label these. What are the walls called? So what's the 30? Opposite. It's opposite your angle. What is the 16? Adjacent. It looks like on this particular problem we're not using the hypotenuse, the biggest wall, we're not using it. So in terms of SOHCAHTOA, I'm using TOA. That's the only one that uses opposite and adjacent. So that's kind of the way that I can kind of narrow it down. Or throw out the ones that we're not using hypotenuse, so they'll throw the ones out with H's on them. So we're using TOA on this particular problem. We're finding the angle in this one. So it's tangent of your angle is opposite over adjacent, and we're canceling out the feet because that's the common label. Again, how I know how to set it up, the acronym TOA actually tells me the second letter goes on the top, third letter goes on the bottom. That's how I know it. Now, to find this answer, you have to use that inverse button. That's how you find angles. It's the only time you use this button on your calculator. We take this tangent function and we do the inverse or arctangent to the other side. So it's that little tangent -1 key. I'll type it in my calculator here in a second so you can see it. So tangent of 30 divided by 16. And then you're going to hit enter. Now, I'll type this in my calculator just so you can see this. All right. Let's see. Okay. So, let's see. Am I recording over here? Yeah. All right. Good. All right. So shift tangent. That gives me the tangent -1. So I hit the little second key. I call it a shift key, but second key. I hit the little tangent key. That gives me a little tangent -1 on my screen. I type in 30 divided by. Just hit the normal division sign. Type in 16. Close the parenthesis off, and hit enter. And it tells me that I'm just going to make sure I'm in the right mode. I'm in degree mode. I just need to make sure of that. So 61.9 degrees. Go about 2 decimal places today, so 61.93. So that'll be my answer for this one. So my answer turned out to be 61.93 degrees. That's my angle. Does that make sense how you do the little inverse button? Okay. This could be for any trig function. I just want to pick a normal one. I consider this a normal problem. You just find the numbers. Now, we have one more example. I only do one more slide. I know that has a bunch of slides. Those are from last week. I didn't delete them. I have one more picture, and this is different than anything we did last week, but it still uses the trig functions, and I want to explain what we're doing here. So, let's say, for instance, that you have 2 people. So here's my person, and here's another person over here. and they are standing a certain distance apart, and this is the question of questions. I want to know the distance between these two people. That is the question of questions. Okay? And they're looking at the same object. So they're looking at, I'm going to ignore the height of each person. So they're looking at the height of an object in front of them. The height of the object is maybe it's a 100-foot building in front of them. And what we have is we have the angle for each person. So maybe this angle for this person was 70 degrees, and this person over here was 32 degrees. And again, I'm ignoring the height of the person. I want to know the distance between them. You know, is it several hundred feet? Is it, 10 feet? What's the distance between them? So here's how I do this. I'm going to find the smaller triangle first. I can find, the missing pieces. Really what I just need to find is the bottom. So I'm going to do the smaller triangle down here first. And what I'm going to do is I'm going to find this number down here. Once I have that, then I'm going to compare it to the bigger triangle, which is the one with the 32 and the 100. And I'm going to find the number on the bottom, which is this number. I'll call it Y. Then to find the distance between the two people, I subtract Y and X. So I find X first, that little tiny piece, to figure out what that person is standing closest to the building. Figure out the bigger distance for the person that's further away from the building, and then subtract them. That tells me the distance between the two people. Does that make sense what I'm about to do? So it's like I'm doing two problems in one. I think you have two of these today. One of them is like this, where you have to find the distance between two people. The second one is where you have to find the height of an object on the top of a cliff. It's the same thing. Basically all they did was they just turned this picture sideways. That's all they did. So you're looking at the bottom of the object and the top of the object, and you're figuring out the height between them. So it's pretty straightforward. Let's do the smaller triangle first. I'm going to try to keep these color-coded. So I'm going to do the yellow triangle, then I'll do the pink triangle. So let's do the yellow one first. Just doing this. This is the opposite wall. This is the adjacent wall to that 70 degrees. So it looks like I'm using TOA on this particular problem. And that's just a random coincidence. I didn't mean to do TOA again. But anyway, we're doing tangent of my 70 degrees is opposite over the adjacent. Since X is on the bottom, I'm going to multiply that across and switch it for the tangent of 70. So I'm going to divide by the tangent of 70. Does everyone make sense of that? Multiply the X over divided by the tangent of 70. So if I type this on my calculator, 100 divided by tangent of 70. I'll show you what I'm typing on my calculator here. So I'm typing this. 100 divided by tangent of 70. That's what I'm typing. Hit enter. And so this is the distance from that first person. So the first person there is standing 36 feet from the building. So 36.3, it's 36.4, let's say. We'll just do, if I rounded it. So this person X is 36.4 feet. That's my X. Now to figure out Y, so I'm going to do the second triangle now. This is the bigger triangle. So I'll kind of highlight this one. So the bigger triangle is this triangle. So that triangle, I'm going to do TOA again. Again, just random coincidence. It is tangent of my 32 is opposite over the adjacent, which is the Y in this case. I'll switch those around, divide. So to find this one out, this is Y is equal to the 100 feet divided by tangent of 32. And the number I'm going to get here for Y, so 100 divided by the tangent of 32 is 160.03 feet. If I rounded 2 decimal places. Now, what is the distance between the two people, roughly? Yeah, about 100, almost 130 feet between them. Just kind of subtracting these two numbers. 123 is probably more accurate. So again, how you actually find the distance for D is you actually subtract you subtract the two numbers. So I'm going to take y and subtract x, and that will give me the distance between the two people. So that's 160.03. Subtract the 36.4, and this is the distance in terms of feet. 123 is pretty darn accurate. 0.63 feet. Whoa. Okay, questions with this newer problem that I have not discussed yet. It's like two problems in one. You have to find one triangle, find the bigger triangle, and then compare the two. This idea is, this is a weird concept. This is how they estimated distance between cities in ancient Egypt. Distance between Cairo and Alexandria and other things like that. So they used the angle to the sun and the shadows on the ground to actually estimate distance between cities, and they were really accurate, doing trig functions of some type, knowing the numbers that were involved for right triangles. It's pretty intense, the mathematics, if you study your history and math. They were insanely accurate. Then they could, from there, they could estimate the radius of the Earth from that. Pretty impressive terms of mathematics with not having calculators on hand to estimate actual raw distances. So far more accurate than we could do now. So all right, questions on this particular problem. Okay, you have your Google question, went live about 10 minutes ago. You can go answer it. It's due on Wednesday. I'll give you some time today to work on it, some time tomorrow. It's due on Wednesday this week. That's probably one of our major big assignments this week. We'll probably have another Google question of the day probably this Wednesday, and maybe one at the end of the week. So if you did not answer any of the Google questions from last week, you probably should. I think my website's up to date, so all the videos are there. I finally got a little bit of time this weekend to actually do that. So the website's 100% up to date. Every video is there. Today after school, I'll update that. So hopefully that makes sense, and you can kind of see the videos, because I know some people like to see those, or they need to see them because they weren't around last week. So, but yeah. So the classwork from last week. See, Abby is gone. Jada, you didn't turn in the stuff from Thursday or Friday last week. Cash, you never turned in the worksheet from last Thursday. Right, you didn't turn in the worksheet from Thursday or Friday's Google question. So make sure you're going in there. So check out those little things. That's just by looking at the Google Classroom, it says it's missing. So I know we had a Google question of the day that was due today. Technically, it was the one I gave you Friday. That was due tonight. Some of you didn't turn that one in yet. Make sure you do that. I posted a Google question each day last week. I think it was like Tuesday, Thursday, and Friday. Make sure you answer those. I think it was a trig function problem. So go in there, answer those, and then today's should have went live. I don't know if it's live yet.
Where did you go school at all this weekend?
Not yet, no. So probably tonight I'll go. So.
What did you say?
We're finally getting enough snow to be able.
Yeah. So hopefully this week I'll go over to Mason and register my sled. I gotta register it yet. It's insured, it's just not registered for the county yet, so I don't want to get picked up by any NR official.
Why you gotta like
That'd
post
be a hefty
assignments
fine.
today?
What?
Why do you have to post assignment today?
Why?
Yeah,
I warned you last week I was going to. I only gave you one big assignment last week.
What?
I only gave you one big assignment last week.
Why? Where's the Google question today?
It's there. It's a worksheet. It's worksheet 4.2.
Oh wait, this is the whole.
Yeah.
Oh, the whole is the question.
Yeah.
Oh. Why aren't you wearing it? What?
Alright, let me take some.
Subi, quit bullying me.
Subi, this is a bully-free zone, sir.